Welcome back to the lab. Delivery came today, which is obvious given the very large box that's on the workbench. This is a used piece of equipment that I'm going to go through start to finish, check everything in, do a calibration on it if it needs to, get some plugins put in it, get everything ready to go. Don't know much about it yet, given the fact that it's still in the box, so we'll see what happens. I have no idea what this is going to entail in terms of the repair and getting everything up and running again. But we will see what happens, but it will work again. And what was in the box is now out of the box. What we have is a Tektronix 7603. It's a 7000 mainframe scope, 3 plugins, so it takes 2 vertical plugins, 1 horizontal plugin, or you can do 2 vertical plugins for XY operation. The only thing I really know about this scope is the seller had it powered on, said it didn't work, didn't display anything on the screen. Could be no high voltage, could work just fine, don't know yet, haven't even turned it on. I do know a little bit about these. There is a much older 7603 right here. This one's a newer unit. It has the fan-cooled regulators on the back. I can tell just by looking at the back of it. So I will go ahead and get the thing hooked up to the Variac and isolation supply. Okay, so I have everything hooked up now. This meter is actually hooked up to show me how much current the unit's drawing. I also have the isolated supply is current limited. I looked at the back of the unit. It said it had 1.9 amps max draw, so I have 4 of the 6 bulbs switched in. Each bulb gives me about a half an amp of current limit. They're 60 watts. So we'll go ahead and turn it on and see what happens. It's come up. The bulbs are glowing a little bit, but they're not showing a short. And it only shows that I'm drawing 0.6 amps, so 600 milliamps, which is fine. Also no smoke, which is good. Okay, so the graticule lights are coming on, which means the power supply is at least waking up. That was something I was pretty sure of because the pictures on the listing had the graticule lights on, had the power supply on, so I knew the power supply was at least turning on, but there doesn't seem to be any shorts. Now, the listing did say there was no high voltage, or there was no trace. Without any of the plugins in, the waveforms aren't right, so it won't develop a trace on the screen. So what I'm going to do now is, because I don't want to fry out any plugins and I don't know what the power supply health is, I'm going to do voltage checks on the power supply, check all the rails, make sure they're all in spec, and then I will take a couple of my spare plugins. We'll see if we can't at least get a trace. So while I wait for the meter to warm up, so it gives me some accurate voltage measurements, just a bit of a tour of the scope. Down here's the main power transformer with a lot of the bulk capacitors on it. Underneath this covers the high voltage section. This is the Z-axis driver, so the Z-axis on the scope is actually brightness. This connector right here is where all the low voltage power supply measurements are taken from. And then this hole down here is where the negative 4 kV supplies tested. Fan, low voltage regulator board is actually behind this cover back here, and behind the fan. The power transistors for the low voltage regulator are on that board under there. That's why the fan blows that way. This is the main interface board for the plugins. One of the faults on these scopes, especially given their age, is these plastic covers right here. These tend to break and crack. There would hold the pins up against the side of the plug-in cards. Actually, I can get a plug-in card here real quick. So here's a plug-in. The way this actually goes in the scope is It slides in the front. And then that connector just pops into place. But when those plastic covers break, they can make intermittent connections and so that's one thing to look out for. This board right here is the readout board. Also controls a lot of the sweep circuits. I have another scope of the exact same frame where this board has been damaged. It shows nothing but 9s and won't show a trace on the screen. Won't show a trace due to the fact that the horizontal drive comes out of here and goes into the horizontal amplifier. So with this board being toast, it just won't show up anything on the screen other than 9s on the readout. So on the other side of the scope, what we have here is this is the vertical amp board. So it's the final stage before the drive pins of the CRT for the vertical amplification of the signal. Up here is the horizontal drive board. So it does the same thing, except it's on the horizontal axis. And then the other side is just more big capacitors by the transformer and the other side of the main interface board. This is the back of the scope with the cover removed. This is the low voltage regulator board. So the pass elements for this are on the other side. They're on a heat sink that the fan blows onto. Not much really going on here except power supply stuff. That was actually a fault on this guy over here on that 7603. One of the drive transistors for one of the power transistors was not working, and the negative 130 or the 130 volt supply was way off. It was like 140 volts, but it ended up being one of these little drive transistors was what fixed that. So, but I'll get some probes, and then we will. I'll check the voltages on the power supply. Well, I am back with the results of the power rail checking, and all of the power supplies are low. Everything. So the entire power supply is out of spec. The good news is the negative 50 volt rail is low, and that's the reference for the rest of the supplies. So I have a suspicion if I bring the negative 50 volt rail back up to negative 50 volts, the rest of the supply should fall in line, because they're all percentage-wise relatively off, close to the same percent. So let me do the negative 50 volt adjustment, and I'll check the supplies again. Okay, as the scope warms up, I am getting ready to start the calibration process. I swapped out the implosion shield from the neutral density to the clear, because I have one of the clear ones, just to get it to show up in the camera better. While I was in there, there's a strip of light bulbs down this side. What I did was I actually swapped them out to LEDs, so I will never have to swap them again. Used white LEDs, so this is what the graticule lights look like with the white LEDs. Shows up real nice. Once I get the frame calibrated and everything done, I will swap it over to the neutral density filter so we can see what that looks like. But the other 7603 that's over here has the neutral density filter on it already, and it looks pretty good. So I'm happy with that. So what I will do now, yesterday I just verified the power supply, used the Keithley meter because it has a large storage capacity, just let it run for a while and just saw what the power supply was doing. My target was a minimum of 2,500 readings off the Keithley, but I also turned it down. So it was 2,500 readings, but it was taking at 10 power line cycles. So what I'm going to do now is I'm going to go get the pull up the service manual for the 7603, and I'm actually going to start going through the calibration process for the frame. That's not going to give me a working scope. To do one of these modular scopes, you have to do the frame, you have to do the vertical, and you have to do the horizontal. What I've done so far is I've set the controls up for the preliminary settings of the service manual. So to not torture the tube, I'm going to roll this off because it wants a 20-minute warm-up. So I don't want the beam just burning on the screen for 20 minutes. The plugins I'm using, the two verticals actually I've calibrated already. They're 7A18s. I have a random 7B53 in there for warm-up. The first thing we got to do is set the negative 50-volt supply. Once I get that set, that'll affect everything. So once I adjust that VR, I'll have to recalibrate the whole frame. But then we'll move on to the display. I'm going to let this warm up for a little bit more, and then I'll hook up the meter. Okay, I'm ready to set the grid bias on the main picture tube. I have this test oscilloscope set up on the Z-axis test point. Everything's all set up. The controls are configured as the manual dictates. So what we're looking for on the grid bias is a spot that just extinguishes. Right about there. All right. Next up is checking the Z-axis DC levels. Okay, for the DC levels, there wasn't really much to show due to the fact that the trace actually should be off screen because you have to turn the intensity up to 100%, so you don't want it burning in the tube. On the Rigel scope, which is my test scope, I got a 65.2, and then when you slow down the time base, I got a 37.2, with the difference being 28 volts. The service manual says I should have between 25 and 35 volts, so that is well within spec, and everything is looking good. Also, since I've done the DC bias, I got some intensity back on the screen, so this tube is actually nice and healthy. Okay, we need to adjust I have all the signal sources set up. We need to adjust the focus control, and then we need to adjust the astigmatism control, which is back on the Z-axis board in the back of the unit. But the adjustment we're looking for is a well-defined display, so that's getting more fuzzy. Oh, that looked better. Actually, let me... Yeah, more fuzzy. Sharper. Fuzzy. More fuzzy. Right about there, I think, for the focus. Now let's do the astigmatism. Oh yeah, that needed adjustment. That looks much better. See if the focus does anything again. I'd say right about there looks good. Try the astigmatism one more time. Yep, right there. Sorry about the bump of the camera. Okay. Okay, number 6 is the trace rotation. It's just a center line centered on the graticule. I screwed it up just on purpose because it was actually pretty good. But I will adjust this real quick. And then I'll be back because I need to be square on. And this is what it looks like after the trace rotation has been adjusted. This is centered. Right here is the very center of the scope. So that's centered on the graticule, so everything looks good there. Next up is the y-axis alignment. I have to move some plugins, so I'll be back. Okay, this is after the y-axis was completed. I had to swap the time base and the calibration fixture in the bottom of the unit, and I got it lined up with the center graticule. It's still a little off at the bottom, but the next up is the geometry alignment, which should correct that. So I'm going to get on with the geometry. Okay, here's the display after the geometry adjustment. This is where this is one of the adjustments, a special piece of gear is needed. You can kind of do this adjustment with a TG501 to get the high and the low markers, to get the 2 time marks running at the same time. You need type 184. So the 184 is able to put out a trigger signal, plus you can have multiple time marks going at the same time. That's a difference between the TG501 and the type 184. The TG501 can do the display markers, but it's not capable of doing multiple time marks at one time. Yeah, so that's the geometry adjustment. Up next is the external z-axis operation. Okay, to check the external z-axis operation, I have a BNCT in the vertical amplifier. I have 2 divisions of signal at 50 kilohertz coming from a 191. I'm about to hook that up to the external input and the front input and the back input. What we should see is the top half of the signal should go away, and it will also intensify the bottom half of the signal. So I will hook up the external now. And that is functioning exactly as it should. I can see, let's see if I can get this to trigger. Oh, there we go. Triggered. So we have an intensification of the bottom half of the signal, and we don't have the top. If I unplug this with it triggered now, there's the sine wave. So everything there is working normally. So next is checking the beam finder button, that it's working correctly and compressing the display as far as it should. So I'll just brighten this up a little bit, and I'll hit the beam finder display, and that compresses into the display area, and we have our sine wave back, and I can get it back on the screen. So the beam finder is working. Okay, I'm gonna adjust the vertical bias now. Need to adjust R486. I have the time base and the calibration fixture all set up. Now I don't have -00 calibration fixture. I have the -01, so mine's a little faster. I don't have a 250 kilohertz option. I have a 1 megahertz option. So I'm going to have to do this at 1 megahertz. But I'm going to adjust the bias resistor, and all I'm looking for now is maximum gain. We'll adjust this real quick. Getting more gain. Okay, now it's compressing again, going backwards. compressing again. Right about there's probably maximum gain. Mine just happens to line up with the graticule lines. Doesn't have to. You're just looking for maximum gain. So now I'm adjusting the triggering gain. Another setting on the calibration fixture. The trace should be right even. So mine was a little off. It was down here. It should be right even with the center line. I'm going to go with right about there. So just checking the vertical gain adjustment. Okay, so I'm adjusting the vertical gain. I just need to line up all of these, get everything squared away. This scope is actually so far in really good shape. It's actually, this may have had the factory calibration on it. Everything's real close. I'm gonna call that good. Now I need to check the vertical gain in the right-hand slot. So I need to move the camera. And there's the vertical gain of the right-hand compartment. Spec is same deflection within plus minus 1% from the 2nd to the 8th traces. So you actually throw out the top and bottom because that's the 1st and the 9th. But then, so the 2nd to the 8th should be within 1% of the other compartment. And it does look pretty good. Okay, this is a 0.4 volt square wave. And all we're doing is checking expansion and compression along the screen. It shouldn't distort as we move it up or down. That looks good. Everything's flat at the top. And it looks good. We don't have any bowing. So that looks really good. Okay, this is the resultant waveform after I did the vertical high frequency compensation. So on these, the important part is this top edge of the wave, getting that as flat as possible. There is 6 different adjustments, capacitors and resistors each, that need to be adjusted. So going through it multiple times to get the flat response curve is good. This one did need a little bit of adjustment, but that's what it is after. Next, we are on to the vertical amplifier bandwidth. The way we've got this started is there's a 3 megahertz sine wave getting fed into the calibration fixture. Frequency response is set, and we've set the amplitude for 6 divisions. So now I have to wind up the frequency until we hit 4.2 divisions. Once we hit 4.2 divisions, tell me what the 3 dB down point is. So what I'll do now is I will wind up signal generator, and we'll see what kind of frequency we're at. I just bumped the amplitude button, meant to move the position button, so let me reset that up. Okay, looks good for the frequency, so wind it up again and get the right knob this time. Okay, we're nowhere near 4.2 yet, so I can go higher in frequency, which is good. So here we go. All right, I'm going to call 4.2 divisions right there. So we have 1, 2, 3, 4.2 along the center graticule. Function generator says we are at 118 megahertz, which is actually good. Spec says we have to be over 110. So we get about 8 more megahertz out of the frame. So it is good to go. No problems with vertical bandwidth. And the service manual has me testing both compartments left and right. So this is the exact same test on the right side. Right side's actually pretty good match. That is also 4.2, and we're getting 117 out of the right side channels. So they are within a megahertz of each other. So we should be good. This is checking the rejection between both channels. They should be attenuated 100 to 1. So we have 8 divisions of display fed in to the left side, and we'll switch to the right. And we have no signal on the right, which is what we should have. I gotta reverse it, and then we'll do the other way. Actually, I'll just do that right now. That in there. So we have 8 divisions of signal, and I will switch over to the left, and we have no signal to speak of on the left. So that is vertical amplifier isolation is working perfectly. Okay, checking the add functionality of the scope. So we have a 0.4 volt square wave signal into input 1. The same signal's fed into channel 2 of the right vertical channel. So we're going to hit add, and we should get double the signal, which we do. So the add functionality looks like it's working just fine. So I've started the alt test, so it should alternate between the traces, but I'm supposed to rotate the time base throughout its range as it's testing. So yeah, that went on the bottom, so we'll speed this up a bit. Yep, we're on the top, speed it up. Bottom, top, bottom, top, bottom, top. Alternating, 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 alternating. And alt mode, we never lose the bottom trace even though it's fast, so alt is working. Okay, checking the chop mode operation. This is the resulting waveform after hooking up the probe and getting it hooked up to the time base. For this one, you actually have to pull the power supply out of the back of the scope slightly because you need to hook up to test point 67, which is actually right smack dab in the middle of the frame behind the power supply. So it's working. Now I got to put the power supply back together again. Okay, so the chopped functionality was the last piece of the vertical section. So that actually concludes the vertical section of the scope. Next up is going to be the triggering system, and we will take a look at that. Okay, I'm into testing the triggering section of the mainframe. Still on the 7603 mainframe. In this case, I have a 100 no, 1 kilohertz square wave going into the input on the left vertical, and then I have the calibration test fixture going into the right vertical, 2 square waves, and the only thing I'm looking for, I don't care about what wave shape is at this point because we haven't calibrated the plugins. The only thing this step is looking for is a stable display as the scope is alternating between the 2 trigger inputs. So we have vert mode and alt, and we have trigger sources in vert mode, so it's triggering off of both waveforms. So this particular test, everything is passing. And then if I set this to the left, only the top waveform should be stable. Set this to left, top waveform should be stable. This one untriggered. If I set it to right, bottom one should trigger and the top one should become unstable. And that's it for that test. That's actually all the triggering testing that the service manual requires. So I'm into calibrating the horizontal deflection system next. Okay, I've set all the test equipment up to do the horizontal amplifier limit centering. Got everything adjusted. There's nothing to see on the 7603. So what I'm going to do is I got the Rigol as the test oscilloscope. I'm going to take a snapshot of that, and then what I will do is I will highlight what I was looking at in the waveform and what I adjusted. I'll get set up for the horizontal amplifier setting. Okay, I'm going to adjust the horizontal centering control. This particular one needs the calibration fixture in the horizontal compartment, and I am looking for the dot. The dot needs to line up with the center line right about there. That looks good. Turn the tube down so we don't burn in the tube. Take a look at that, and then okay, checking the horizontal amplifier low frequency linearity. Got all the test equipment hooked up. Have a vertical amplifier in the horizontal point, 2 divisions of square wave coming down. The sweep is actually going this way at the moment because the horizontal time base is in the vertical. And what I need to do is roll it back and forth, and what I'm looking for is expansion or compression of waveform as I sweep it left and right on the screen. Actually, I'm a bit wider than 2 divisions. So back this down just a little bit. Two divisions. Little bit over 2 divisions. But I'm looking for not more than 0.1 divisions, so that's fine. Little bit over 2 divisions, but not bad. Go the other way. 2 divisions. Two divisions. Two divisions. And 2 divisions. So actually that way's not bad. Okay, next I got to pull out the vertical amplifier, install the signal calibrator, and do the same thing for high frequency. Okay, this is the high frequency gain. So I'm not liking what I'm seeing. Well within adjustment range, but I'm off over here. Traces should line up exactly on the graticule lines, and they're not. So I need to adjust. R512 is what needs adjustment. fiddly adjustment. I think right there is going to do it, just about. And it says interaction with R512, recheck steps 22 and 23. So I'll have to go back and recheck all those now. But I'll be back when that gets done. The limit centering was good, but the amplifier centering moved a little bit. So I'm going to readjust that. That's perfectly centered now. Okay, and that's what the display looks like after the second round of adjustments. Everything does look good, so I'm going to move on to the high-frequency timing. Okay, I have all the pre-work done. High-frequency timing, it is off. Do need to adjust it. These are 10 nanosecond markers, so for this one, because it's a sine wave and not a time mark, I'm looking at the tops of the sine wave, so the top should be hitting each division, and they're not. So very touchy adjustment. What I need to do is I need to adjust the high frequency timing, a 37,000 serial number. It is C588. So I will get that adjusted right now. I think I'm going to switch my time mark generator from the 184 to the TG501. I think my 10 nanosecond markers may be off on my 184 because I can't bring this into adjustment. So let me get that set up real quick and I'll be right back. Okay, well, as I tried the other way, realized I was actually tuning the wrong capacitor, so I had to go back, set everything back up, get started again. It looks like I have everything kind of in good shape, but in doing this adjustment, I can tell this time base has a horrible sweep linearity problem. So I'm going to need to calibrate that out. That's actually a time base problem, not a frame problem. So where I'm adjusting is I'm adjusting at this point right here, the second division, and the 9th division over here. So time mark, time mark. Everything should be lining up on these time marks, but this time base needs to be calibrated. It's pretty far off. Pretty far off is relative. We are working with 10 nanosecond pulses, so that is also pushing a 53 pretty hard. But I will get in, and then I have to do the last two adjustments, the C66 and C58 586. Okay, this is actually a compromise adjustment. This one's not going to be perfect, but what the adjustment's looking for is on the 5 nanoseconds, because it's 10 nanosecond time marks, so every other peak, or peak every other division. On the 10 nanosecond time marks, peak every division. This is a very touchy adjustment because it's pushing this frame about as fast as it can go, because we're all the way down on the time base, 10x multipliers on. So this is a very touchy adjustment, but this is the 5 nanosecond peak after I've adjusted it. Everything is working correctly, so what I said before about time marks being off and things like that, that's not accurate. Everything's actually working right now. This is the 10, and if I move that over, we have good 10 nanosecond time marks, but it's a compromise between the two, so as best you can get on the 10 with as best you can get on the 5. So that looks real good, and on the 10 that looks really good as well. So with the low frequency generator set to 35 kilohertz, feeding a signal into the scope, just checking to make sure the opening on this line is less than 0.28 divisions. It is, so that means we have a good phase shift between the channels. Service manual says it's less than 2 degrees. So everything looks good there, so on to the next step. Okay, I have 8 divisions of 50 kilohertz going into the scope, checking the horizontal bandwidth. So what I'm going to do is I'm going to wind the frequency generator up to 50 kilohertz, 2 megahertz. It's at 50 kilohertz right now. And we should get 5.6 divisions of display. If we do, the vertical bandwidth passes. That's 2 megahertz. Still have pretty much 8 divisions worth of display, so this scope has lots of horizontal bandwidth. So we're good there. Section of the service manual is the Z-axis calibration. Okay, I've got the Z-axis square wave compensation done. I have it set up on the Rigol scope as opposed to using the frame to do its own compensation. So I will take a screenshot of the Rigol and I'll cut it in after this section. I just squared off the top end corner of the step and got that looking good. So the next thing up is the autofocus compensation and operating levels. Okay, I finished the autofocus compensation and operating levels. So just to show you what that looks like, this is just a 50 kilohertz sine wave, but there's a very low intensity. We have great focus. It's about mid-range. It's still in very good focus. And then we have good focus at the top end too. And that's with this focus control, not even adjusted, just centered. Autofocus looks like it's working very, very well. And also this tube is really healthy. This is just a low time tube. So very happy with that. So next up is adjusting the calibrator for the probe compensation. Not much to see for the calibrator adjustment. This potentiometer is adjusted for cal. You move this jumper to DC, and then on the front panel you use a DC voltmeter. I was able to adjust it to 4.001 volts, so well within spec. So it looks like it's healthy. I also checked the 0.4 and 40 millivolt calibrator outputs, and they are squared away as well. So everything looks ready to go. So I got to turn the scope back off, move that jumper back down so it's putting out the square wave it's supposed to. The last two steps in checking in one of these frames and calibrating these frames is checking the readout and the signal output on the back of the scope. The signal outputs are all good, everything's working there. I just wanted to show the readout that everything was good there and it did not need to be adjusted. I'll turn all the readouts on real quick. So the way the readouts work on this is if this was a 4-base scope, there'd be one more down here for the second time base. This is not a 4-base scope. This is only a 3. So you have left and right top trace, left and right bottom trace, because I have 2 dual channel amplifiers in here. So this is actually capable of displaying 4 traces at a time. It's not a dual beam scope, but it is capable of alternating back and forth for 4 traces. And then we have the 1 time base up here, so everything looks right with the readout. Nothing needs to be adjusted there. Thanks for stopping by the lab today. Hopefully this video is of use to anybody who would like to undertake the same procedure in calibrating one of these old 7000 scopes. Hang around, there'll be plenty of videos coming, and check back often.